Hello, how are you all? So I have uploaded a video on tautomerism. Please do watch it, and if you like it, please like, share and subscribe. So here I'm back with two important questions that are very much important from exam perspective. So as you can see in this first example, there is this compound like this, and you are given the reagent piperidine, and three product will be formed. Now see what is the structure of piperidine. First, you have to know what is the structure of piperidine and what will be the role of piperidine. Here, piperidine acts as base. Okay, it acts as base. So it will find the most acidic hydrogen here. Now see, this is the acidic hydrogen here. Now you'll say why so? Because if this carbanion here is formed, suppose I am taking this left side counterpart only. Suppose here this is the counterpart, left counterpart. I'm not taking the count of this right side part. Now see, this is the resonance stabilized one. First of all, this is aromatic benzene ring, this is aromatic. Now you see, if you consider this ring, this is also aromatic. 1 2 3 4 5 6 pi electrons. That means this ring also becomes aromatic, and it's resonance stabilized. No, it is resonance stabilized. So that's why this is very much stabilized. So conjugate base here is stabilized. So this piperidine will simply abstract this proton and form a carbanion here. Now what will happen? Now I'll write the total part here. Okay. The double bond, and here is the carbanion, NH and then PH and then COOH. Now you see what will happen. This negative charge forms a bond here. It's a basically decarboxylation reaction. So you see this part, it will be out in the form of CO2. And what will happen? So the end product will look like this. Right? And then this part, that is CO2, very stable. Okay. Now then here it will be first NH minus. It will be NH minus, and then this NH minus will abstract a proton and will form, I'm writing the end product, PHCOOH. So these are three products, A, B and C. Hope you understood. Now let's move to the next example. So here you see two compounds are given, but they are same, only the two isomer. This is trans because these two groups are on opposite side, and this is cis. So the acidity order. Now you see, if I am taking first the trans one, now see, I have to see that in which isomer this acid, this conjugate base is most stable. So CO minus here, it will be most stable. Now here see, the CH3 group is having plus I effect. It is also having plus I effect, but they are on opposite sides. So these vectors cancel each other ultimately, isn't it? So they cancel each other. So ultimately what? The net plus I effect approximately 0. But here in the cis counterpart, if you see, now I am taking only the conjugate base for better understanding. You see, it is having plus I effect in this direction. It is also having plus I effect this direction. So ultimately it is in this direction net. So ultimately what happens? They are pushing electrons. Plus I effect means electron displacement. That means it is already carbanion and more electron. They are pushing the electrons toward this carbanion. That means they are making this conjugate base more unstable. This conjugate base becomes unstable because they are already having negative charge. So if it gets dispersed, only then it will be stabilized. But here they are only pushing the electron. That means it becomes less stable compared to this one. if I take this a carbanion. So that's the reason the trans is more stable than cis. Okay. So these are the two questions, and I hope you understood the concept, and if you have any doubt, please let me know. Thank you. Bye bye.